Hello children, how are you all? Hope you all are fine and doing well. Dear children, in a previous class, we discussed the concepts of upthrust. There we discussed what actually upthrust is, on which factor does it depend, and even we discussed the Archimedes principle in detail. In today's session, we will be solving the numericals based on upthrust and related concepts. Before going to start the numerical children, just let us recall once again what actually upthrust is. Children, what actually upthrust is? Come on, think. What actually upthrust is? So, got it? Yes. So, when a body is immersed partially or wholly in a fluid, children, fluid means it might be liquid or gas. What happens? It experiences an upward force. That upward force only we can call it as a upthrust. Got it? But how to calculate? How to calculate the upthrust? Children, look at here. If W1 is the weight of the solid in air, whereas W2 is the weight of the solid when it is immersed in a fluid. Then how to calculate the upthrust, dear children? Upthrust can be calculated FB is equal to weight of the solid in air minus weight of the solid when immersed in a fluid. Children, this weight of the solid when it is immersed in a fluid only we can call it as a apparent weight. We can call it as a apparent weight. So, in some numericals, buoyant force is given, weight of the solid in air is given. They'll ask us to calculate the apparent weight. Then how to calculate the apparent weight? W2 is equal to weight of the solid in air minus buoyant force. So, this is one formula to calculate the buoyant force. And children, sometimes what happens, volume of the body immersed in a fluid is given and the density of the liquid is given. Then how can we calculate the buoyant force? Children, just you think, on which factors does the buoyant force depend? It depends on volume of the body immersed, density of the liquid in which a body is immersed, and even acceleration due to gravity also. Yes. So, next formula which we are going to use to calculate the buoyant force is FB is equal to VI rho L G. VI rho L G. Children, these two are very important formulas to calculate the buoyant force. In most of the numericals, we are going to use either this formula or this formula. Even some cases, we use this formula also. For what we use this formula? To calculate the apparent weight. To calculate the apparent weight of the body. Okay? Fine. This is about buoyant force. Children, then what is Archimedes principle? Just let us recall. Children, come on, think. What actually Archimedes principle? Can you recall? Yes. What does it say? What does it state? Children, here Archimedes principle states that when a body is immersed partially or wholly in a fluid, what happens? It experiences some upthrust. At the same time, it displaces some amount of water. So, mathematically, we can say like this. That is, whenever a body is immersed partially or wholly in a fluid, it experiences some upthrust. At the same time, it displaces some amount of water, and that water has some weight, that is WL. So, this weight of the liquid displaced is equal to the buoyant force experienced by that body. Buoyant force experienced by that body. So, let us say once again, whenever a body is immersed partially or wholly in a fluid, it experiences a buoyant force which is equal to the weight of the liquid displaced by a submerged part of it. So, this is what actually Archimedes principle state. Okay, children. So, these are the concepts should be in our mind so that what happens, we can solve the numericals in a simple manner. Now, let us start the first numerical. So, first numerical. Children, in this numerical, it is given that it is a solid and its volume is 100 centimeter cube. Try to understand, children. Solid of volume 100 centimeter cube, and when its weight is measured, it is noted that 5 kgf. Children, don't forget that here it is 5 kgf is the weight of the solid of volume 100 centimeter cube in air, that we are representing with a W1. Now what happened? This entire body is completely immersed in a liquid. This entire body is completely immersed in a liquid. Then what will happen? Again when we measure its weight, it is recorded as W2. Children, don't get confused here. W1 is the weight of the solid in air, whereas W2 is the weight of the solid when it is immersed completely in a liquid of density 1.8 into 10 power 3 kg per meter cube. This is the density of the liquid in which solid is immersed completely. Now children, what happens? Just you tell me whether W1 will be greater or a W2. Children, think. W1 is the weight of the solid in air. W2 is the weight of the solid when completely immersed in a liquid. Which one do you think is a more and which one do you think is a less? Yes, obviously W2 is less than that of the W1. Here W1 is called true weight, W2 is called apparent weight. Why W2 is less than that of the W1? Because as the body is immersed in a fluid, children, it experiences an upward force. It experiences an upward force is called buoyant force. So due to the buoyant force, what happens? It means the weight appears as if it is going to lose. Okay, but in fact it is not going to lose just because of buoyant force only. Now we have to calculate what is the buoyant force, how much buoyant force acting, and what is the apparent weight, that is weight of the solid in a liquid. Now first let us write the data in detail. Children, here W1 is given, how much it is given? 5 kgf. Now volume of the solid is given V, it is given 100 centimeter cube. Children, as it is given 100 centimeter cube, let us convert into meter cube here. We know that 1 centimeter is equal to 10 power minus 2 meters. So this can be written as 1 centimeter cube is equal to 10 power minus 6 meter cube. Now V is equal to 100 centimeter cube. This can be written as 100 into 1 centimeter cube. In the place of that, let us write 10 power minus 6 meter cube. Let it be. Okay, fine. Next, density of the liquid is given. Density of the liquid is given 1.8 into 10 power 3 kg per meter cube. Now first let us calculate the upthrust. Children, what is the formula to calculate the upthrust? Just recall here. So upthrust is equal to, here we know this, upthrust FB is equal to volume of the body immersed, density of the liquid, and G. Okay. Now density of the liquid you substitute here. Before that, volume, let us write 100 into 10 power minus 6, and density of the liquid is 1.8 into 10 power cube, and the G value, children, G value if you substitute either 9.8 or 10, you will get answer in Newton. But here already weight of the solid in air is given kgfs. So if you want answer in terms of kgf, let it be G value like that only. G value like that only. Now if you simplify this, how much do you get here? So this is going to be 10 power minus 4, okay, into this will be 1.8 into 10 power 3 into G. Here 10 power 3 is there, here 10 power minus 4 is there. So 10 power minus 1 is left. 10 power minus 1 is left. So this will be 10 power minus 1 into 1.8 G. So this is going to be 0.18 G. This can be written as 0.18 kgf. 0.18 kgf. So children, this is what actually buoyant force which is acting on the body when it is completely immersed in a liquid of density 1.8 into 10 power 3 kg per meter cube. This is the first one what they are asking us to calculate. Now children, here only second one they are asking. What they are asking? They are asking us to calculate the apparent weight of the body. Means when a body is kept completely in a liquid, what happens? What is the weight shown by the spring balance? So that is second one. So here children, it's very clear that true weight is equal to, that is W1 is equal to true weight is equal to buoyant force plus apparent weight. This is a very important, it should remember. Now we need to calculate the W2. So W2 can be written as true weight minus buoyant force. So true weight is how much, dear children? 5. Buoyant force is 0.18. So the answer is going to be 4.82 kgf. So this is a weight of the body when completely immersed in a fluid. So this is how actually we have to do step by step. Okay, fine. Now let us see the second numerical. Children, in this numerical, it is given that, look at here, it is given that, here is again same, almost more or less the same concept only. Here is children a solid. When its weight is measured, initially it is in air only, let us measure its weight. It is given as 450 gram force. 450 gram force. So this 450 gram force is going to be 450 gram force, children. 450 gram force is a W1. W1 means what? Weight of the solid in air. Now it is completely immersed in a liquid, and it is recorded as how much it is approximately. Let us, it's a 310. Sorry, not approximately. It is given 310 gram force. Still try to understand. 450 gram force is the weight of the solid in air, whereas 310 gram force is its weight where it completely immersed in a fluid. Now we are asked to calculate 3 things here. We have to calculate the volume of the solid and the buoyant force acting on it. And third one is what? Here we have to calculate the loss of weight of the body only. See, look at here, loss of the weight of the body. And what we do is that we will find the volume of the body at the end. First we will calculate what is the apparent weight, what is the loss of weight. Then at the end we will calculate the volume of the body. Okay, fine. First one let us calculate here. So here children, how can we calculate that here? How can we calculate a buoyant force here? Children, here buoyant force is equal to buoyant force. So let us write symbol, right? So why to write completely buoyant force? So it's a buoyant force is equal to, we know that W1 minus W2. That is, W1 is the weight of the solid in air, W2 is the weight of the solid when it is immersed in a liquid. That is also called as apparent weight. So children, this is W1, this is given W2. Let us substitute here directly. This is going to be 450 minus 310. So this will be 140 gram force. 140 gram force, this is. Okay, first one we got. And the second one, we need to calculate the loss of weight of the solid or body. Children, remember that it's very important. Here I want to tell you one very important thing is that whenever a body is immersed in a fluid, it experiences an upward force, children. If it experiences more upward force, more will be the loss of weight. If it experiences less upward force, less will be the loss of weight. Which means what here? Buoyant force is a measure of loss of weight of the body, or else loss of weight of the body is measure of buoyant force. Both are equal only. So loss of weight of body is equal to nothing but buoyant force acting on the body. Buoyant force acting on the body. So how much it will be? So same way we can calculate, that is 140 gram force only. 140 gram force only, that's it. Okay, fine. Third one, this is very important. Very means very much important. Volume of the body, how to calculate volume of the body. So here, in a textbook also it is given answer 140. So we think, oh, it's three answers are same, 140, 140, 140. But here is 140 gram force, 140 gram force, but volume is centimeter cube. In the place of gram force, how do you think we will get centimeter cube? So directly we should not by heart. Let us not by heart like a 140 centimeter cube only. It is not that. Let us see, children, here. So here they are asking us to calculate the volume of the body. Volume of the body immersed. Volume of the body immersed. So now let us take buoyant force is equal to how much we got? Buoyant force FB is equal to, we got 140 gram force. Gram force means we can write 140 G. Am I right? So don't get confused. Don't get confused here. Okay, na? It's a gram force only. It's a gram force only. But we can write as a 140 into G also. Okay, na? Fine. And FB is equal to what, teacher? Buoyant force formula. Volume of the solid immersed, density of the liquid into G is equal to 140 into G. So G gets cancelled. Here liquid is what? Water. So density of liquid is equal to, in centimeter, in a CJ system, 1 gram per centimeter cube. So let us substitute its value. Let us substitute its value. So it is V into 1 gram per centimeter cube, okay, now, is equal to 140 grams it will be now. Grams it will be. Okay, na? So this GR also don't get confused. It is grams now. Clear? So now this grams gets cancelled. Here 1 by centimeter cube. When it is taken this side, it will become, it is multiplied. So here volume of the solid is equal to 140 centimeter cube. That's it. 140 centimeter cube. So children, this is how we have to calculate. Again I am telling you, don't think that because it's a 140 will, okay. But how we are getting is very important. How we are getting, again we have taken the concept of buoyant force only to calculate the volume of the body immersed. Volume of the body immersed. Okay, copy it. Children, here look at the third question here. So third question, it is given that two balls it is. One is hollow iron ball A, whereas one more is solid iron ball. And it is given that volume of the here iron ball, that is hollow iron ball. Children, hollow means what here? Inside empty completely. Here solid iron ball means here is something like this. So it's like a tennis ball. It's like, cricket ball, grease ball, which we will use for international purpose. Okay, fine. It is given that, children, hollow iron ball volume is given 15 centimeter cube and its mass is given 12 grams. Solid iron ball also mass is same only, but its volume is not given. Then what we have to do? We have to calculate its density. We have to calculate its volume, because here its density also given, because both are made up of iron only and density of iron is given, and both are placed, one is hollow, another is solid. Both are placed on the surface of water. And we know that the density of water is 1 gram per centimeter cube in a CJ system. Now we need to calculate which ball will experience more upthrust, and which one, means we have to calculate individually, then we have to see which one will sink, which one will float. That's very important. Okay, fine. Now look at here, children. First let us calculate the upthrust acting on iron ball, hollow iron ball. So for this first let us calculate. Look at here. So here let us calculate. We know that here, okay, upthrust acting on A. Let us say FA. FA is a upthrust acting on the hollow iron ball. We know the formula: volume of the body, density of the liquid into G. Volume is given how much, children? It is 15. Density of the liquid is given 1 into G. So this can be written as 15 gram force. Children, this is buoyant force acting on hollow iron ball. But like this, we cannot calculate directly the upthrust acting on solid iron ball. Why? Because we don't know the volume. First, let us calculate the volume of the solid iron ball. So, let us calculate. We know that density is equal to, children, density is equal to mass per volume. From this, we can rewrite like this: volume is equal to mass per density. Okay. So, its volume is equal to, mass is given how much? 12 grams. Density of iron is how much? 8. Density of iron is 8. Now, look at here. This is going to be 4 3s are 4 2s are. So, this is V is equal to 1.5 centimeter cube. That's it. Now, got it. We got the volume of the solid iron ball. Now, let us calculate this one. Buoyant force acting on a ball B. Okay. Volume of the body, density of the liquid into G. So, V is given 1.5, not given, we calculated, and the density of the liquid is 1 into G. So, look at here, children, FB is equal to, this is 1.5 GF gram force. 1.5 gram force. Children, here, now just let us compare the upthrust acting on hollow iron ball, upthrust acting on buoyant force. Which one will sink first? Let us see. We know that it's very clear that here FA is greater than FB, which means what here? More upthrust is acting on hollow iron ball. As more upthrust is acting, what will happen? It will float. Whereas here less upthrust is acting on this solid iron ball, then what will happen? Solid iron ball will sink. So what you have to write for answer D? You have to write that as a upthrust on solid iron ball B is decreasing. So what will happen? This will sink. This will sink, whereas this body will float. This body will float. Okay. Now let us move to the numerical 4. Children, it is given that a solid of density is given. So density of the solid is given 5000 kg per meter cube. And its weight in air is given, that is W is equal to 0.5 kgf, and this body of what we can say density 5000 kg per meter cube is completely immersed in a liquid. What is that liquid? Water. And here density of water, that is liquid, is given, that is 1000 kg per meter cube. Now they are asking us to calculate the apparent weight of the solid. Apparent weight of the solid. Children, this is 0.5 kgf is what? It's a true weight. It is true weight. It is true weight. Generally, we can represent it with a W1. But when we want to calculate apparent weight, we must know that how much buoyant force is acting on a body of density 5000 kg per meter cube. Then if you want to calculate the upthrust acting on that body, we must know its volume. We must know its volume. Children, what is the idea? Look at here. Look at here. When this body is immersed completely. So let us say W2 is its weight. Okay. And W1 is when it is in air. Okay. W2 will be less than that of W1. Because of what? Buoyant force. Because of what? Buoyant force. So here it is clear that true weight is equal to apparent weight plus buoyant force. Then we need to calculate apparent weight is equal to W1 minus FB. W1 minus FB. So that is what means from true weight we need to subtract the buoyant force. But buoyant force is not given, that we have to calculate. If you want to calculate, we must know the volume of the body immersed, that is not known. So that we have to calculate. How? Here rho is given, that is the density of the solid is given, and weight of the solid is given. Children, as weight of the solid is 0.5 kgf, it's very clear that mass can be 0.5 kg, that's it. Okay. And we know that here volume is equal to mass by density. So mass is 0.5 and density is 5000. 5000 it is meter cube. That's it. Now we got even volume also. Now let us use this. Buoyant force is equal to volume of the solid, density of the liquid into G value. So this can be V is 0.5 by it is 5000 into density of the liquid is how much? It is 1000 and G it is. Okay na? So 3 zeros cancel. 0.5 by 5 is how much? 0.1 kgf. 0.1 kgf. This is buoyant force. Still it is not answer. They are asking us to calculate what we can say apparent weight. So how can we calculate apparent weight? True weight minus buoyant force. So that is W2. Children, this W2 is nothing but what? Apparent weight. Apparent weight, which is equal to W1 is how much? Weight of the solid in air, that is 0.5 minus it is how much? 0.1. So the apparent weight will be 0.4 kgf. This is the what we can say weight of the solid when it is immersed in water. Okay, copy. Now let us move to the numerical 5. Look at here, numerical 5 children. Children, it is given that let us take here is a container in which water is taken. So two spheres, let us say sphere A, sphere B, sphere A, sphere B. Now it's not one is hollow, another is solid, both are solids only. But the thing is that A is made up of with wood, B is made up of with iron. Okay, na? Let us take here solid A, sphere. So it is sphere A is made up of with wood and it is made up of with sphere B is made up of with iron. So it is given that both have same volume, that is the volume of sphere A is how much? V is equal to 100 centimeter cube and this volume also 100 centimeter cube only. Both volumes 100 meter cube only. And the density of the wood is given 0.3 gram per centimeter cube, whereas the density of iron is given 8.9 gram per centimeter cube. Now they are asking us to calculate first what is the weight of each sphere, and when they are placed in a water, calculate the upthrust acting on it, and even we have to check which one will float, which one will sink. So three things we have to calculate. Okay, first let us calculate the weight of the solid, weight of the each sphere. Children, as it's a sphere, we need to calculate here weight. Weight is equal to what? W is equal to m into g, mass into g. But in a question, mass is not given at all. But without knowing the mass, how can we calculate the weight? So first we have to calculate the mass. From that we can calculate the weight of the each sphere. Children, we know that W is equal to mg. Okay, W is equal to mg. But we know that density is equal to mass per volume. So mass can be written as what? Density into volume. Because here density is given, volume is given. So we can calculate. So here weight can be calculated like this. Density into volume into G. So this is a formula which we are going to use now. So let us calculate first its weight here. W is equal to, so density is equal to 0.3, volume is 100 into G. So if you can see this one, it's a 30 gram force. 30 gram force is a weight of the sphere made up of with the wood. Whereas come to this one here, W is equal to density is 8.9 into 100 into G. This is going to be W is equal to, it is 890 gram force. This is a weight of the sphere made up of with iron, Now let us calculate the buoyant force acting on both spheres. First let us calculate buoyant force acting on sphere A. Children, we know that what is the buoyant force formula? Again I am telling you, buoyant force is equal to volume of the body, density of the liquid and G. Density liquid into G. Children, now look at here for this. So, buoyant force acting on sphere A. Volume of the body, how much is given? 100 centimeter cube. That is 100. Density of the liquid, here liquid is what? Water. So, the density of liquid is given 1 gram per centimeter cube. And children, it is a standard value, whether it is given or not. If it is a water means, in the CJ system means we must take 1 gram per centimeter cube. In SS system means 1000 kg per meter cube, we must take it. Okay, fine. So, that is, and density is a L, 1 only, it is G only. So, buoyant force acting on sphere A is how much, children? 100 gram force. 100 gram force. Now, let us calculate the buoyant force acting on sphere B made up with iron. So, that is FB is equal to, so volume of the sphere is how much? 100 centimeter cube, that is 100. Density of the liquid, it is 1 only, and G. So, this will be how much? It is 100 gram force, that is buoyant force acting on B only. That means what we can notice, children, both will experience same upthrust. Once again you think, children, you may get one doubt. Sir, one is made up of with a wood, another one is made up of with iron. How can we say that both will experience same upthrust? Something went wrong, isn't it? No, it's not that. So let us recall the factors affecting the buoyant force. Buoyant force experienced by solid, it does not depend on the density of the solid. It does not depend on the material with which it is made. Rather, it depends on the volume of the body immersed, density of the liquid. Look at here, both having same volume and both are placed in same liquid only. So, without doing only, we can say that both will experience same force. So, in exam, they will ask you to find the ratio of these, what buoyant force experienced by these two spheres. You can write here, FA is to FB is equal to 1:1. Now, children, of course, with this you cannot say that. Both will float or both will sink. It's not that. Then how can we answer? Yes. Now we have to think about the densities. Density. Children, we know very well, whenever density of solid is greater than that of the density of liquid, what will happen? It will sink. So, now look at here, density of iron ball is greater than the density of water. So, it will sink. What about this, what we can say, sphere made up of with wood? Again, I am telling you, we know that whenever density of solid is less than the density of liquid, what will happen? It will float. So, in a given question, the density of the, what we can say, sphere made up of with wood is how much? Density of wood is 0.3, that is less than that of the density of water. So, it will float. That's it. So, we are going to decide whether the ball will sink or that is sphere will sink or float based on the densities. Okay, children. So, this is how we can calculate the weights of each sphere, and here we calculated the buoyant force experienced by the two spheres and we compared even, and this is just we concluded which one will sink and which one will float. Now, let us move to the numerical 6. Children, just first try to understand the question. What actually given, what is asked, what we have to calculate, that is very important. So, we should have a clarity about the data, what actually given. That's very easy. It's not a matter of remembering formula or selecting formula, substituting value. It's not that. We have to understand the, what we can say, numerical. For that, we have to read at least once, twice you can read it. Then we'll get a grip. Just visualize that numerical. It's not like reading the numerical. Visualize that. Means make a rough diagram. So, it's a better thing is that whenever you are going to solve the numerical, first make a rough sketch of that numerical. Means complete that statement, whatever is given, that must be made as a diagram. Then you will get a picture. Then you will get a command and you can do it very easily. Okay, fine. Now, moving to next question number 6. It is given that a mass of a solid is given 13.5 kg. 13.5 kg. Children, as mass is 13.5 kg, it is given, but weight is not given. Can we calculate its weight? Obviously, we can calculate. So its weight is going to be 13.5 kgf, because we know that W is equal to mg. Children, don't get confused. W is equal to mg. By using this formula, we calculate the weight, and its volume is given. Children, the volume of the solid is given 15 into 10 power minus 3 meter cube. So its mass is given, and we calculated its weight, and even its volume is given, and it is completely immersed in a water. Liquid, it's given water only, and the density of water is how much? So look at here, all are in SI system only. So the density of water, that is liquid, is known, that is 1000 kg per meter cube. Now it is asked us to calculate, we have to calculate the upthrust acting on the body, apparent weight, and we have to see whether that body, whether it will float or sink. So these are the three tasks which we have in front of us, which we have to solve it. Okay. First, let us calculate the buoyant force acting, children. So buoyant force formula is equal to V rho G. V rho G. So that is volume of the solid, density of the liquid, and its G value. Okay. Now, then how can we calculate the volume of the solid? Volume of the solid is given. Okay. Let us write here 15 into 10 power minus 3. Density of the liquid is 1000. It can be written as even 10 power 3 kg per meter cube. Let us substitute 10 power 3 into G. Both will get cancelled. So here buoyant force is equal to 15 gram force. Now children, second one, we need to calculate. We need to just calculate, or we need to conclude, or we need to talk whether body will float or not. Then how can we say that? Children, already we know that. See, we have three cases. If the weight of the solid is greater than the buoyant force, it will sink. Whereas, when the weight of the body in air, when it is less than that of the buoyant force, what will happen? It will float. It will float. Now look at here. Weight of the solid is how much? 13.5 kgf. But buoyant force is how much? 15 gram force. Which means what here? Weight of the solid, that is 13.5 gram force, is less than that of the buoyant force, that is 15 gram force. So here body will float. It is a floating body. Body will float. Now third one, they are asking us to calculate the weight of the floating body. What is the weight of the floating body? Children, when the body will float? When the body will float? When W is equal to FB. W is equal to FB. When this condition is fulfilled, then what will happen? It will float. So, while floating, children, while floating, its weight is equal to FB only. That is 13.5 gram force. 13.5 gram force. Then only what will happen? It will float. Then only it will float. Children, these conditions are very important to understand the concept. Okay, na? Fine. Now we will do the numerical 7. Yes. Now let us move to the numerical 7 here. Children, it is given that numerical 7. It is given that it is a piece. It is made up of the brass. Its weight in air is 175 gram force. W1 is the weight of that particular material made up of the brass is 175 gram force. 175 gram force. When it is immersed in a water, is given it as a 150 gram force. And it is where it is immersed in a liquid of density water, it is given water only. And we know that water density is how much, children? It is 1 gram per centimeter cube. That's it. They are asking us to calculate what is its volume. What is the volume? We have to calculate, and we have to see why when it is immersed in a water, why its weight is less than that of its true weight. Children, in a second numerical only we calculated. So when weight of the solid in air, weight of the solid in a liquid is given, how to calculate the volume. So for that we should know the loss of weight of that body. That is the buoyant force, we must know that. So children, here buoyant force or loss in weight is equal to W1 minus W2. This is going to be 175 minus 150. So children, this can be FB is equal to 25 G. F, 25 GF. Children, 25 GF means what? 25 into G, that is 9.8 grams. Remember, it's very, very important. GF means what? You have to multiply with a 9.8. Okay, if you want mass actually. Okay, na? Fine. Now here, FB is equal to, we know the volume of the solid, density of the liquid into G. Clear? And this can be written as 25 G into grams. Into gram force. No need to write that. 25 G. This can be written as. So here, volume to be calculated. Density of the liquid, that is 1 gram per centimeter cube. Children, don't get confused. We may have confusion. That's what I am writing GR. That's what we are writing. It's a GR I am writing. Don't get confused. It's GR I am writing. Okay, na? Fine. And into G as usual. As it is G. Okay, na? Now this is here gram will be there. Don't get, because it's a W is equal to mg. This is M. Try to understand. 25 grams. 25 grams. When it is multiplied with G, you will get a weight. Children, W is equal to mg. W. So here M is what? 25 grams. Into G as usual it will be there. Into G as usual it will be there. Okay, na? Now let me write here. 25 grams into G. G gets cancelled. Grams gets cancelled. So volume of the body is equal to 25 centimeter cube. 25 centimeter cube. Fine. Now second question it is asked, why its weight in water is less than its actual weight? The reason is that when it is immersed in a water, children, as we know that what happened, it experienced some upthrust. So due to that just upthrust only, it appears as if it loses its weight, but it happens only as long as the body is in what we can say water only. The moment when it is taken again, what happened? It will have its actual weight. Got it? So again I am telling you. So here volume, whenever body weight in air, body weight in liquid is given, of course that difference how much will get? That is going to be the answer in centimeter cube. But how to calculate? This is a method to calculate. Okay, just copy it. Okay, moving to the next numerical, it's numerical 8. Children, here it is given a cube. Okay, try to understand. Here is a cube. And it is given that each side of the cube is 5 centimeter. Each side is given 5 centimeter. Then as he said is given, we can calculate volume easily. So children, volume is equal to what? 5 centimeter into length into breadth into height. 5 centimeter, 5 centimeter. So this is gonna be 125 centimeter cube. And its density also given 9 gram per centimeter cube. Density of that solid is given 9 grams per centimeter cube. Children, as volume is given, density is given. Can't we calculate its mass? Yes, we can calculate its mass. Mass is equal to volume into density. This is gonna be 125 into 9. This will become 1125 grams. Children, as mass is 1125 grams, then what will be the W value? W is equal to mg, means mass is multiplied by G, then if we will get actually weight of that solid here. So W is equal to, we know that it is mg. Okay, so don't get confused. Here G means what? Here 9.8. Here G is what? Actual grams. Don't get confused. So then W is going to be 1125 gram force. So this is the information regarding this solid. Children, this solid, try to understand this complete solid, children. What actually given here? Look at this. Here is a liquid in which a solid is suspended with a thread. Solid is suspended with a thread. And obviously on this solid, children, buoyant force will be acting upward direction and it will have some apparent weight. It will be acting downward direction. And tension in this thread will be acting upward direction, tension only. Now we need to calculate the tension developed in the string. Tension developed in the string. Children, this tension in equilibrium is balanced by this weight. Means what? This tension is nothing but what is an apparent weight. The tension is nothing but what is an apparent weight only. Then how to calculate here? Tension is equal to, how to calculate apparent weight? True weight minus buoyant force. So to calculate true weight, children, see true weight, see T for what actually is a tension. Tension is equal to the apparent weight, try to understand. So how to calculate apparent weight here? True weight minus buoyant force. So that apparent weight will be the tension developed in the string. Here W is equal to what? Already W value is given 1125. Just we need to calculate the upthrust, then we will get the tension developed in the string. Now let us calculate the buoyant force, children. Buoyant force formula is equal to V rho L G. Children, what is the volume of the solid? Volume of the solid is given 125. Density of the liquid. Children, here liquid is not a water. It is given with a density of 1.2 gram per centimeter cube. So it is 1.2 into G. So this is gonna be 150 gram force. Children, 150 gram force is a buoyant force acting on the body when it is immersed in a liquid of density 1.2 gram per centimeter cube. Now what we need to calculate? We need to calculate the tension developed. We need to calculate the tension developed. So tension developed is equal to W, the true weight minus buoyant force. True weight is equal to how much, children? It we got as a 1125 minus 150. This is gonna be 975 gram force. 975 gram force is a tension developed in the string. Tension developed in the string. If you will convert into newtons, you will get a 9.75 Newton. This equal to the 9.75 Newton. If you can convert, if you want, you can keep answering gram force, and that is 975 gram force. Children, try to understand this diagram carefully. So why we are taking tension is equal to W minus FB? Because here whatever the weight the body has when it is placed in a liquid is nothing but equal to tension only. So how, just you think about this, how can you calculate apparent weight? Apparent weight can be calculated by like this, true weight minus buoyant force. So this is nothing but what actually? WA only. So this is what actually we have to understand. Okay, just copy it. Now look at here, children. Numerical 9. Children, it is given that a solid is like, it's immersed, completely immersed in a water, and such that its dimensions are 50 centimeters, 50 centimeters, 50 centimeters. That is length, breadth, height is a cube when it is given. Then it is asked us to calculate the upthrust acting on the body. As length, breadth, height is given, children, we can calculate the volume. How can we calculate the volume? So volume is equal to, let us convert into meter cubes, SI system. That is 125. This can be written as 10 power 3 into, children, 1 centimeter cube is equal to how much? 10 power minus 6 meter cube. So this can be 0.125 meter cube. So this is the volume of the solid is completely immersed in a water. And children, density of water is how much? Density of water, that is liquid, is equal to 1000 kg per meter cube. And G value is given to children, it is 9.8. Don't get confused. Don't get confused. It is given in terms of Newton per kg. Children, Newton per kg or meter per second square. Both are same only. No need to get confused. Now let us calculate the upthrust acting on the body. Children, upthrust FB is equal to V rho L G. Okay. Now let us substitute the values, that is 0.125. Okay. This can be written as, children, 125 into 10 power minus 3 meter cube, right? Yes. So let us write that only. So that calculation will become easy. Into 10 power minus 3. Density of the liquid will be 1000, that is 10 power 3 into G value is 9.8. This will get cancelled. So it will be 125 into it is 9.8 only. 125 into 9.8 will be how much, children? It will be 1225 newtons. So this is a buoyant force acting on a body when it is complete with the dimensions. Length is 50 centimeters, breadth is 50 centimeters, height is 50 centimeters. When it is completely immersed in a water, this is a buoyant force experienced by that particular body. Okay, fine. In a 10th numerical, children, in 10th numerical, it is given that here a body of mass 3.5 kg is immersed in a water. Then displaces some amount of water, right? So it is given that, children, the amount of water or liquid displaced only 1000 centimeter cube. So children, this is volume of the liquid displaced. Now first we have to calculate the volume of the solid, that is volume of the body immersed. Children, we know that volume of the body immersed is equal to the volume of the liquid displaced by it. Displaced by it. So here means what? Indirectly, the volume of the liquid displaced only, volume of the solid is how much, children? It will be 1000 centimeter cube. So let us convert this, children. Here Vi is equal to 1000 can be written as 10 power 3 and a centimeter cube is equal to 10 power minus 6 meter cube. That is 10 power minus 6 meter cube. So volume of the solid we got as 10 power minus 3 meter cube. Okay, fine. One we have calculated. Now we need to calculate the buoyant force acting on this solid when it is immersed. Solid of mass 3.5 kg. Children, here buoyant force is equal to volume of the solid, density of the liquid into G. Volume we know that 10 power minus 3. Density of the liquid, it is a water, that is 10 power 3, that is 1000 kg per meter cube, and G value only. Children, 10 power minus 3 into 10 power 3, don't say 0, it is 1. Okay, so buoyant force is equal to 1 kgf. Buoyant force is equal to 1 kgf. Fine. Third one, what we need to calculate, children? We need to calculate the apparent weight. Then to calculate the apparent weight, we must know the true weight, because children, here apparent weight is equal to true weight minus buoyant force. Here buoyant force is calculated, okay, 1 kg, but true weight is not given. That we have to calculate. How, children? Mass is given, right? That is 3.5 kg, and we know that W is equal to mg. W is equal to mg. So true weight is going to be 3.5 kgf. That's it. 3.5 kgf. Now substitute here. This is going to be 3.5 minus 1. So this will be 2.5 kgf is a apparent weight of the solid of mass 3.5 kg. So children, these are the numericals based on upthrust. Children, once again I am saying you, it is not that simply it's reading the numerical, selecting or just recalling the formula and putting the value. It's not that. Try to read the question once or twice. Try to understand the numerical and try to visualize the numerical. Try to visualize the numerical means whatever the numerical which you are reading, children, try to make a rough diagram so that we will get a full clarity. Then obviously we will get any type of numerical. Okay, children, just for this you need a practice. If you can practice, obviously you can do any type of numerical based on what? Upthrust. Okay, children, thank you so much. All the very best.